Hello, Abigail. Thank you for your question. Again, I did, as I mentioned in the email to you, that I was receiving these links through another email, so this is why I didn't respond in sooner. This question is basically a graphing question that asks you to graph the function. It also asks you to find the domain and range. So whenever we are looking at a domain, we are looking at the x values that are valid for the specific function, if you want to think of it this way. When we're thinking about a range, we are thinking about the y values that are valid. So the f of x, basically f of x is y, these values that are valid for this domain. So you told me that you did look at the question example, or the view example in the question help, and you really did not know where the values of x came from. Now, in order for us to, before I go and I look at the example and explain it to you, any function that you have, any f of x function that you have, in order for you to find the values of f of x and to graph this function, you have to plug in or substitute values for x into this function and find f of x. So for instance, if I choose x equals to 0, therefore the square root of 0 is equal to 0, minus 4 is minus 4. So therefore for x equals to 0, y is equal to minus 4. So you have to find multiple coordinates. As you can see, this function is not a straight line. So you're going to have a curve. And whenever you have a curve, you don't want to stick with 2 coordinates. You want to go 3 or more. So at least you want to choose 3 values for x and find 3 values for f of x in order to plot your curve. When you do that, you're going to be able to find the range because that tells you which values for y are actually on this function. Now, this function is a unique function because it has a square root. As we learned previously, the square root of a function, whenever you're looking at a square root of a function, you cannot have a negative value under that function. So the square root of negative 1 is not a real number. The square root of negative 2, negative 5, negative 16, negative 80 is not a real number. So you're kind of limited with only positive values of x or x equal to 0. So this is where they actually got their numbers. As you can see in the question help, they first tried negative 1, and this is just to tell you that negative 1 cannot be, you cannot replace x by negative 1 because that will give you a not a real number, and that cannot be applied to this function. Therefore, you're only limited with positive values of x, including 0. So start with 0. It doesn't have to be 0, 1, 4. It could be 0, 1, 9. The reason why they chose 0, 1, 4 is because it's easy for you to take that number out of the square root. You don't want to be left with decimals. So for instance, the square root of 0 is 0. Square root of 1 is 1. The square root of 2, it's going to be a decimal number when you calculate it on the calculator. So in order to make this process easier, they chose a number that can be taken out of the square root. The square root of 4 is basically equal to 2. Because 4 is 2 to the power of 2, you can take that 2 out of the square root. This is why they chose these numbers. Now, you could always choose 0, 1, as I said, 9, if you want 16, if you want, any number that can be taken out of the square root. It doesn't matter. You could choose any number. But these are just for to simplify your process, to simplify the graphing, they use these numbers. And then, once you do that, you don't want to just do the square root of 0 and this is your f of x. You also have a minus 9 in the equation. So you want to do 0 minus 9. This gives you minus 9 for f of x. And remember, f of x is the y value on the function. If you replace the square root x by 1, the square root of 1 is 1. 1 minus 9 is minus 8. The square root of 4 is 2. 2 minus 9 is minus 7. Therefore, now you have 3 numbers. You can plot these 3 numbers on your graph, actually 3 coordinates because each one has an x value and a y value. Plot them on your coordinates. Once you do that, you connect them, you get a curve. After you get that curve, excellent. Now you know which option to select, but you also do have to give the function its domain along and its range. Remember what I told you, when you're looking at a domain, you're looking at the values of x that are valid for this function. In this case, you know already that the x can only be 0 and any positive number. So including 0, we do a closed bracket because 0 can be included all the way up to infinity, and this is positive infinity because any positive number you can plug in here and you can get a value for f of x. Okay, now when you want to look at the range you're looking at what values for y are possible for this function. And as you can see, the y in this case, which is different for your own example, but I'm showing you for your own problem, but I'm showing you the example here and you can apply it to your homework question, is -9. -9 is the smallest value of y, and it can go all the way up to positive infinity. So this again is how you solve this problem, how you determine the range and the domain. If you have any more questions, please know that I'm here and I will answer them as soon as possible. Thank you so much for sending the question over, and I look forward to hearing back from you.